All right. Welcome to Denmark. This is the happiest country on earth, according to many surveys. Um, Unfortunately, this is not a happy topic in Denmark. We're looking at what turns out to be an increasing rate of in-hospital falls that result in major injuries. And this is a fairly recent article. It's in a peer-reviewed journal. It's got a nice substantial data set. And most importantly, they conducted a logistic regression as the heart of this study, which is why I want to go through this article. If you haven't had a chance to at least skim through portions of the article yourself, I suggest you pausing this and going back, doing that, and then coming back to watch the video. I'm going to comment on some of the highlights of the article, specifically the logistic regression parts. So first of all, why logistic regression here? Why did they choose to use this? Well, remember, logistic regression is when we have an outcome variable, so some variable that we're interested in, that has two separate values on the variable. And in this particular case, we're interested in falls that result in major injuries. So either a patient had one of these falls or they didn't have one of these falls. That's a yes or no variable. It makes it a perfect ground for a logistic regression. What we can then do is gather these other variables, in this case, some of their chronic conditions, that are predictor variables to tell us how does that impact the probability that they would end up, or the odds that they would end up in either the group that did have a major injury from a fall in the hospital and the group that did not. So that's why this is a perfect logistic regression context here. We have some of the results here. There's a nice visual down there, so I want to take a look at that. Real quickly, I want to talk about this first table and what's going on here. So the way they did this study, they got a lot of data on these people, these elderly patients, or senior citizens, not necessarily elderly, who had fallen and resulted in a major injury. Probably. You can read this. Is that it? This right here. It was possible there were patients slipping in here that did not fall in the hospital that resulted in a major injury. Maybe someone got in a fight with another patient and had trauma to a bone, and they could have also been counted as having a fall. That's a necessary evil when you're dealing with large data sets. You have to accept some amount of ambiguity in the data, and that part is discussed right here. But for the most part, we're going to assume that these really were falls that resulted in major injuries. These are the cases. For each case, they took the gender, the age, the time they were admitted, and found 5 controls who matched as closely as possible to the person who had fallen and experienced a major injury in the hospital. Now, ideally, what we'd like to see is high p-values here, which sounds strange because typically a researcher would want to see low p-values to show that there's something significant, some difference going on. In this case, we want the controls to be, and the researchers want the controls to be as close to the cases as possible. So ideally, we'd like to see no significant difference. However, the only place we really see that is down here. Maybe diabetes was non-significant, but gender and age were certainly non-significant. How in the world could we get a p-value of 1? That means that we see the exact same rate of females to males in this group as we do in this group. Well, that's because they intentionally controlled that. If you have Johnny, the 68-year-old man who falls, gets a major injury, he's one of their cases, they're going to match him with 5 male patients of about the same age, which is why this number right here multiplied by 5 gives you exactly this number, and this number here multiplied by 5 gives you exactly this number. So they controlled this p-value to make sure that there was no significant difference in gender. Now here they can't control on everything. It's just not possible. What they could do is statistically do some controls, but in terms of the physical actual patients and their qualities, they could only control a couple things. That they chose to focus on gender and age. So again, what do you do with the fact that the cases and the controls aren't exactly the same? Well, at least they were transparent and reported that. It is a limitation of the study. If you were interested in a specific condition, you might take a look at how far off the percentages actually were in the cases and controls. This is where the join point regression comes in. I actually had to Google that. It's just a way of telling if there's a change in time, which is something they were interested in. Notice also here they're doing per 100,000 hospital days, which is nice because otherwise if we see an increase, it might just be because the population itself is increasing or some other lurking variable like that. This at least controls for that, so it doesn't really matter how long people were staying in the hospital or how many people there were in the country. This kind of adjusts for that. Okay, let's zip down now to this. Here's where the heart of what I really want to focus on, and that's the odds ratios that they report. So these conditions were our predictor variables, same as in multiple regression. We have these predictor variables, and what we want to know is coming into the hospital with one of these conditions. These were prior conditions prior to this fall that took place or didn't take place, prior to being admitted to the hospital. Does this put them at a greater risk for having a fall, a major fall, while they're in the hospital? So let's take a look at the first one and what that means. So we have dementia. We can see a little plot here and an odds ratio, confidence interval. What all is going on here? Well, let's start with the odds ratio, the 2.34. What that tells us is the patients, based on the data set we're looking at here, the patients who were admitted into the hospital with dementia were 2.34. The odds of them falling and having a major injury while they were in the hospital is 2.344 times as high as the patients who did not come in with dementia. A pretty drastic difference. And this is the actual difference that they saw in the data set, in the thousands of Danish patients that they mentioned. What we would really want to do is generalize beyond those specific Danish patients into a larger population and try to figure out, well, what is the increased risk for someone with dementia? And here's where they create a confidence interval. So they say, best case scenario, someone with dementia is 1.8, 1.9 times as likely. The odds of them falling is 1.89 times as high as someone who does not have dementia falling and having a major injury. Worst case scenario, it might be almost 3 times as likely for someone with dementia to fall and have one of these major injuries. So what's going on visually here? Well, an odds ratio of 1 would be that there's no difference at all. This predictor variable, whether someone has that or does not have that, has absolutely no bearing on whatever your outcome is. In this case, the falling and having a major injury. That would be an odds ratio of 1. This picture shows us the black dot is where our sample was. In this case, the Danish patients was 2.34. And this little line here tells us the confidence interval. So it's probably somewhere between here and here, the actual odds ratio for a larger population. Notice that 1 is not in between those two numbers. 1.00 is not in between these numbers. Visually, we can see that this line represents 1, and it's not in between these 2 points. It's not part of that confidence interval. What we could say is that means it's a statistically significant result. If there were a p-value here, there's not. If there were, the p-value would be less than 0.05. Because 1 is not, even in the best case scenario for dementia patients here, 1 is not included in there. So we're pretty sure that having dementia increases your chance of a major fall and getting an injury. Same thing can be said for osteoporosis, stroke, depression. These next couple here, the pulmonary disease and the Parkinson's disease, notice that 1 also is not part of that confidence interval, just barely. So we would see a statistically significant result for these also, even though it would just squeak into that range. So the reality is it really might not make a difference at all, or it might range up to 1.4 times as likely to have a fall, someone with this condition. For these two, diabetes and heart failure, we did see a little bit more of the patients in the study, the diabetes patients, having these major related falls. However, because of the variability, it could just be due to randomness, the people we happen to get in our sample. It's very possible that a patient with diabetes is less likely to have a major related fall, or all the way up to 1.5 times as likely to have one of these falls. Same thing for heart failure, so it's somewhat inconclusive, although, as we've talked about throughout the course, we can interpret these confidence intervals. So just because it's not a statistically significant result, we can see that, worst case scenario, these diabetic patients could be 1.5 times as likely to fall. And then we have one down here, this heart disease is actually significantly less likely to have one of these falls-related major injuries because it's so far to the left that odds ratio of 1 isn't even part of that, so significantly less likely. If we go to the conclusions of the article where they talk about dementia are associated with in-hospital falls-related major injuries, notice that word associated. They're saying we definitely have a correlation. We're not going to go so far as to say that this is a causation, but enough that these are significant predictors. Notice that they cut it off their Parkinson's disease. So they really did stop right there with the ones that did not have 1 inside of the confidence interval, that were completely above that odds ratio of 1. So diabetes, heart failure, this type of heart disease don't get mentioned in that because they were not significantly above. Now, if you're a nurse who works mostly with diabetic patients, I would look at this and say, yeah, okay, diabetic patients weren't mentioned in the results here, but we do see evidence that they could be up to 1.5 times as likely to fall. I would probably want to see a little more research on that. So they talk about that in the What's New. That's kind of a cool little section. I haven't seen that box much in studies. The other thing, just to finish off on a different note, and we don't even have to understand joint point regression to understand these results across time. They're saying that there was an increase in falls. That's one of the things they were looking at. 3.2% increase per year across this time frame. Although they put that in a confidence interval nicely. Love the confidence intervals they're using here. So the reality is it's probably between a 0.6% increase and a 5.8. Even worst case scenario, there is some kind of increase here. This is worst case scenario, or best case, I should say. It's still a positive number. And then if you look at the more recent years, 2007 to 2012, that average change is a lot higher, somewhere between 5 and 18% per year. They do discuss that this could be because maybe only the more brittle patients are now coming to the hospital for various reasons. Still, we are seeing that this is an increasing problem in Denmark, and then we might want to look at whether or not this would generalize to hospitals in the US.